version. All right. So here's the idea. Practice guide you're holding on to is due on the 4th. That's the Monday we're back. Make a copy over break. That way when you're back, you can turn in my original version and you can study your copy. Or just use my website and study that, or just take pictures of it. Semester test on Tuesday. And then Wednesday, this is something I forgot to warn you guys yesterday. Wednesday next week, or on the day after our semester test, I want to do a book check. So I want to see that you have your physical book in your hand, you have the book cover on it. So it's going to give you a little bit of time over break to find out where you put it. Maybe it's in your locker, maybe it's at home, maybe it's in your car. Just find it over break and bring it in, and I want it the day after semester test.
Mine's at home, and it's going to stay at home unless you remind me.
Okay, I'm going to send out reminders. It will be a part of the emails I send out. You're probably going to receive a few emails from me over the next couple days. I think I already sent out emails today, this morning, about tomorrow's Zoom. So if you can't make it or anything like that, maybe you can. I already sent out those this morning because I knew that tonight, like the video for today's lesson will go live, but it will be super late tonight. The reason why we have a quad for basketball games, and I can't start uploading it until after that. So it'll be late tonight.
What are we talking late,
like 1:30 late in the morning.
I'll
so,
do that.
You do that?
Yeah.
You stay up to do that?
Oh yeah. There's days where I'm up till 3 in the morning, 4 in the morning.
Why?
So gotta get it done. So it won't get done if I come tomorrow.
You're an animal.
So, all right.
I bet you.
So,
I'm low at night.
I bet you just went.
oh, I sometimes I tried that, but then the problem is ask questions, and it wants to be confirming, and it wants to have title. There's a lot of stuff to
I
do
bet
with it.
you just
So,
went ham in college.
No.
Like,
I was
get the
fine.
work done at
So-
1
so-
and have fun till the sun.
Wait, say that again?
Get the work done at 1 and have fun till the sun.
Oh, okay, all right. I see what you're saying. Now, all right. Yeah, that's you're pretty clever. All right. Now, okay, all right. All right. Anyway, today we're going to do 2 questions. Tomorrow we have 1. Tomorrow's the race format question, so we'll get to that. That'll be a majority of what we do tomorrow. I will send out a link tomorrow after school that kind of highlights all the videos. So it'll have a link to all the addresses for the videos. The reason why is that some people tend to forget what the address is, or they just tend to forget it. If it's in your email, you might be more likely to click on it and kind of go check it out. So that'll be, and I'll send that out, and then I'll send out reminders for like the practice test due date and book check and all that good stuff. And I'll send another one like a day before we are back, or 2 days before we're back, just so you're kind of aware like things are coming up. Okay? All right. Late work is due tomorrow. That's anything in the Google Classroom. I know some of you have been doing a pretty good job of getting everything submitted to me. Get it in, so that way over break I can get it all up to date. Okay? All right.
These problems aren't going to take very long.
No, they're not. They're going to go pretty quick. We only have 2.
Do over break?
What? Nothing?
Stupid. What's it called?
I don't know.
Speech.
Okay. All right.
That sucks.
Okay. All right.
Hey, you want to be our audience?
Shh. No. All right. So,
We're just going to come to your house.
no. All right. So, practice semester test here. Question number 1, you had to graph the perpendicular and parallel. Make sure you're graphing both in the same graph. If you're at home, you're going to have to just draw this on paper, maybe for zooming or something like that. Okay. 2 and 3, you have to use your calculator. You need to know how to use this. Okay, if you don't know how to use the calculator, that would be a great question today or the Monday we're back, because that'll be a review day.
Remind me to ask you how to
Okay.
use it after.
Okay,
today.
yep. Okay. 4, graphing, it'll be a sine or cosine problem. It'll be a horizontal shift, vertical shift, and then the amplitude number, so be prepared for that. 5, it'll be some type of problem where I'll have a horizontal asymptote, no slant, but I'll have a horizontal, and you're kind of going from there. It'll be factorable. What was that? Is she? Oh, they are. I didn't hear it. Did you guys hear it?
Hey, Morgan.
That's how bad my hearing is. Oh, okay. Sorry. I'm so sorry, guys. We haven't got to any new problems yet, so you're good. So sorry. I couldn't hear it. I didn't realize you guys were trying to zoom in. So you haven't missed anything. We're just reviewing the questions we did previously. All right. So 5, graphing. 6, this is one we did the other day. We're finding the first derivative using the differential quotient. I think that was the one we did yesterday. 7 we did yesterday, where we had to do the product rule, where you had to do the first derivative of the first times the second plus the derivative of the second times the first. And then the last question we did yesterday was the quotient rule. You did not have to simplify those problems. You just had to show that you know what the formula is. So good timing on coming in. Sorry. Good text of Vanessa. So good catch on that. So, all right. Let's go to number 9 today. We have 9 and 10. We're only doing 2 problems today, 2 new ones today. We're going to get to it. So we have chain rule today. These these you also do not have to simplify. I'd probably actually add that as a direction on the actual on the semester test that says do not simplify.
In red.
So okay, you won't be able to see it. So, all right, because it won't print right. Because I don't print color.
Why?
It's just I don't have the ink. So, all right. Hey, so let's walk through this. So, first derivative. Okay, let's do chain rules. So, drop the 3 out front. Now, when we drop the 3 out front, we have to subtract 1 off the power. Now, the inside, when you do that for a normal chain rule, should not change. So this will still be the 3x squared plus the 4x and plus the 1. Okay, those should not change. Now, after that, we have to multiply by the derivative of the inside. And that would be the 6x to the first and then plus 4. That's it. That's all I needed. That's chain rule. It'll be something like that. Now, what you need to be prepared for on chain rule, whatever is on the inside. So it could be a trig function, and you'll have to take the derivative of it. So I could put the e numbers inside there. I could put the number to the power. I could put a natural log. Something that you know how to take a derivative of. So you have to be able to take that second, right? It'll be a first derivative only. All the problems up till now have been first derivatives only because the latest unit we're in, we're on second derivatives. So that'll be one of the questions we look at tomorrow, okay? All right, questions with that? That is the answer. That's all I'm looking for.
So the first one of finding derivatives chain rule will probably be pretty simple.
Yeah.
But the next one will be one of those.
Yeah. Yep.
Using like arc.
Yep. Okay, 10, as you can see it. We have arctan. This will be a first derivative. It's a chain rule with all the arctan. It'll be arctan, arcsine, or arc cosine. It'll be one of those. So you got to know how to use it. And they could have exponentials. They could have other things in them. But it's just meant to. I want to see if you know how to do the arctan, arc cosine, arcsine problems.
1 over
So.
x plus 1 squared or something, right?
It's 1 over 1 plus x squared, and then you have the square roots where you have the 1 minus x squared, right? So in fact, what page is that found in your textbook? The page in your textbook that has all these arc sines and cosines, they are found on page 157. So if you really want to know those arc sines and cosines, go to page 157 of your textbook, because obviously we have a book check coming up on the Wednesday after our semester test. That specifically has all the arc sines and cosines. It might spill over to 157. So, okay, all right. Shh. Let's walk through the first derivative here. We're only doing first derivative only. Now for arc tangent, it's kind of like a chain rule. It's going to be 1 over 1 plus, now, hey, shh. 1 plus something squared. Okay, I'm going to stop here if we're going to be talking because I don't need to go on. I know how to do this stuff. I don't need to hear myself talk.
I like listening to your voice.
So. All right, for arctan, it's 1 plus something squared, right? Some item x squared. Well, on my item, this is the inside, right? This is that variable they used for your angle. That item has to still stay here. It's going to stay inside that little parenthesis there. So your problem will look like this. It's going to be 1 plus, and then yeah, it'll be kind of a larger parenthesis because that item's kind of large, which is fine. That's just a normal part that you're going to have there. You have it squared, right? You don't need to simplify it. You don't need to actually square it or anything like that. Now, just like the chain rule, we're going to multiply by the derivative of the inside. So the derivative of the inside is just a polynomial. Yours is kind of easy. The derivative of that polynomial is 3x squared minus 18x and then plus 24.
So it'll 100% be an arc something.
Yeah, it's going to be an arc sine or arc cosine or tangent. It'll be one of those three, guaranteed, 100%. And then it'll be something in the parentheses behind it that you can take a derivative easily. That's it. That's the answer right
What are
there.
the other ways you could do it on the inside? Like E, what's the other?
Yeah, so the other things I could have on the inside. So it could be Like the function that is on the inside could be like an e to the something x, right? That power could be something crazy. Remember, the derivative of that is just e to the x. It's the original item, and then you take it times the derivative of what the power is. In my case, the derivative of the power is 1. Whoa, what happened there?
So what are the chances it'll be E on the test?
That's the only other way.
I don't know. There's e, there's exponentials where it's like some number to a power. It could be the natural log of something. Like,
What are the chances it'll be like that? Like,
Isn't the natural log the same thing as arctan?
like this?
I don't know.
Or
I don't know. I don't know what the percentage would be.
You have-
33.3%. I'm making that up. I have no idea.
You think you watch it?
So I know. I'd try not to.
LN's the same as arctan, is it?
ln when you so when you do the natural log of something, right? And that's the original function. The derivative of it. Wow, why does it keep? Wow, my palm is just really messing with this thing today.
Is it sweaty?
No, it's not. I wonder if it's my shirt kind of messing with it. All right. Anyway, when you do the derivative of the natural log, it's gonna be 1 over the item that's in the parenthesis, and then times the derivative of whatever that item is. So
exactly like what we just did.
yeah, the only difference is for tangents the 1 plus something squared, but for natural log it's just 1 over whatever that item is. Right?
And then if it's a number to it.
Yeah. So then if your function is like I'll just make this up
So
8
literally just
8 to the x.
Is 1 plus. Okay.
This would be natural log of 8,
Times the
and then times the original, and then times the derivative of whatever's in the power.
Okay.
So because it's like almost like the e. Thing.
Wait, so it's not going to say fx ln 8 to the x? We're going to write out
No.
8 to the x is natural log.
Yeah, that's the natural log part. These are the starting things. So it'd be either this, or it'd be this, or it'd be
Well, it could
this.
be-
So
You could have that one, but inside the parentheses it would be like
Get
8
rid
to
of
the
that.
next, and then you just flip them.
yeah,
And I just multiply it.
yeah.
Well, Isaac's not bringing wall.
Don't get rid of the.
I'm not. Now, is there anything specifically that you want to see? Something inside something else? We can do a crazy chain rule or anything.
She wants to.
I'm good, Ward.
Okay, I'm gonna stop there. That's it. It was pretty easy today. We just wanted to do 2. That's it. I want to keep it pretty basic. The ones on your special test are not meant to be difficult by any means. They're not. It's meant to be. It's quick hitters that you can find derivatives really quick if you know your rules. Yeah. So, any questions from you guys at home? I know you guys missed the original instructions. Semester test is on Tuesday. So if you're here, great. If you're not, we'll take it via Zoom. I think you guys are here anyway. Then the practice guide for you guys is due on Monday, so you'll turn that in to me. Just email it to me, and then unless you're here, then you can turn it in. And then we have a book check on the day after our semester test. That's Wednesday. A physical book, so I need to see it with the book cover and the numbers. So make sure you have it. Okay. All late work, JMC stuff, Google Classroom. Make sure you're getting that submitted to me. By tomorrow. I want that stuff by tomorrow night. If you have any late work that you haven't turned in yet. So, any questions for me, guys? Okay, good. Hopefully I'll see you guys after break. Hopefully you guys are taking care of yourselves and you're healthy. So, and we'll see you later, guys. I'll see you tomorrow. Bye, guys. Good seeing you.
You know.
Are you kidding me? He's getting you with I'll talk to him.